Hello, good afternoon. If it's afternoon for you, it's afternoon for me in this case. Um, if you are new and don't know, sorry, let me shuffle a few more of these windows around. If you're new and don't know, though, my name is Tim. I go by Foamy Guy on GitHub and Discord. Go one more. All right. I need this window. All right. Yes, my name is Tim. Like I said, I go by Foamy Guy on GitHub and Discord. This is the Deep Dive, a weekly live stream here on Fridays at 4 p.m. Central Time, U.S. Central Time, which is my time, or 5 p.m. Eastern, 2 p.m. Pacific, which is usually how it's billed, 5 p.m. Eastern, 2 p.m. Pacific. It is a live stream that was started by Scott Shawcroft, lead developer of CircuitPython. He is out this week. He was working early this week, but took the latter half of the week off, so I'm here filling in on the Deep Dive live stream. The stream happens each week at this time, and when he's around, he's usually diving into whatever is the up-and-coming stuff in CircuitPython. He's been doing a lot of work recently on the Zephyr port and the I think it's native sim that can run tests and all kinds of stuff. I think display IO, maybe he was working on porting to Zephyr, so that's the kind of stuff he's been up to lately. When I am here, I am usually working a little bit higher level than that. We're working on drivers or infrastructure or projects, most typically, although occasionally we dive into the core as well when I'm around. But that is that. If you are brand new and have no idea what I'm talking about, then first of all, thanks for sticking through all of that, even though you didn't know what's going on. But you can learn more about the sort of main overarching topic of the stream, which is CircuitPython. You can learn more at circuitpython.org right here. This is a version of Python that is designed to run on tiny computers that are called microcontrollers. If you use CircuitPython, the way it typically works, you'll plug this device into your computer. It will show up like a thumb drive. You can edit a Python code file on that drive, and when you save it, it will run the Python code that you save into that file. And then your code can interface with whatever other hardware peripherals you connect up. So in some cases, these devices are very bare. They just have a bunch of pins that you can hook up whatever you want. In other cases, they have more built-in hardware, like this Fruit Jam device right here, which is sort of a little mini computer board. So it actually has a lot of hardware built in. It has like a USB hub, so it can have 2 ports. Has a HDMI-shaped plug over there that carries DVI video. It has a TLV audio DAC with a 3.5mm. It has an SD card. It has Wi-Fi. It has some NeoPixels, some buttons. And then in this case, it also does still have a load of header as well, which you can plug in other stuff too. So different devices have different built-in capabilities, but CircuitPython is just a way of programming these little microcontroller devices to make these other peripherals, whether they're built-in or you connected them with wires or whatever, to get those things to do what you want. As always, we will say huge thanks to Adafruit. Adafruit is a hardware and software company based out of New York. Their website is adafruit.com. They make CircuitPython possible by paying a team of folks, including Scott and myself, as well as some others, to work on CircuitPython. They also support some other developers, paying other developers to work on other open source projects as well that are not CircuitPython. So if you appreciate CircuitPython or you appreciate open source development, one of the easiest ways you can help support some open source development is by purchasing hardware from them at their website, adafruit.com. So that is the intro, and then this week I am going to be jumping right in. Let me check one thing here real fast. Where did this go? Let's see here. Did it switch? Yeah. Okay. One just never updated the preview. That's fine though. Okay, so I'm jumping right in. For anyone also who doesn't know, I do stream on Tuesdays at 10 a.m. Central Time. That's 10 a.m. Central US or 11 a.m. Eastern, 8 a.m. Pacific. And on my stream this past Tuesday, one of the things that I discovered essentially was a bit of a problem potentially, I'm not sure it's a problem, but I think it may be, with the APDS 9999 sensor, which is a proximity and light sensor. But I quickly moved on, not during the stream. I kind of discovered this during the stream, but we still used this sensor. We kind of just shifted over to a different methodology to make it work for what I was doing at the time. But in the time since, I kind of got off of the APDS 999 sensor and started working on the true thing that was in the works at the time for me, which was this VCNL 4030. I don't know if it'll want to focus in front of all this other stuff, but like it might have tried for a second, but no. VCNL 4030. So wrote a bunch of tests for this one, which is a similar type of sensor. It is also a light and proximity sensor. It just had only very recently arrived into my hands right before I got on the stream Tuesday. So I started out with this one. We did a bit with it. But then basically after the stream, I soldered this up and started using it. If you are interested in those tests, you can find them over in the VCNL 4030 Circuit Python repo under hardware tests right here. So these are the tests that ended up coming out of that work that I started on Tuesday. But now I wanted to circle back to this APDS and see if we can figure out what's up with it. So the main thing I was having an issue with was it seemed like the interrupts were not quite firing correctly. So I'm going to... I should have brought a flashlight. I meant to do that. That's all right. I'm going to use, I think, this automatic interrupt test. This has the actual interrupt pin, which is on the breakout here. In this case, it's got soldered pin, and there's this white wire right here, which is ultimately leading back into the fruit jam. That should be on pin D8. I'll double check just to make sure. I also have... Actually, it doesn't show here. You know where we can find out for sure, though, is actually back on the VCNL repo, because in the hardware tests here, interrupt pin, this is all wired the exact same as it was when I wrote this. So D8 is correct for that. Over to a different pie charm there. Let's see. Okay, so we have interrupt pin is connected to DA. We have NeoPixels. I want to use a different NeoPixel pin. Actually, we need that to be, I think, D9? D10? No, that can't be right. D7. Go ahead and copy this to the board. Pin D7, we actually do have 8 pixels. This is hard-coded for 5, so we could just easily change that. It starts on 0 brightness. And it sets the color to white, and then I guess it's going to use brightness later on to change to actually turn the lights on. Yeah. Okay, now this is doing interrupts only for the light. So the thing specifically that I did have issues with on Tuesday was around the proximity. So we'll see if this one works. So it looks like this is basically going to hook up to the NeoPixels and run through a series of brightnesses. Like 5% brightness, 10%, 20, 30, 50, 70, 85, 100. And as it runs through those series of brightnesses, it's going to be checking the interrupt pin to make sure that it triggers when we are below the low threshold and above the high threshold. This is a strange construct. All past equals print result and all past. Think print result must return a true false in addition to printing? Yeah. Interesting. It's kind of awkward. Could refactor that. Okay. Where does it get its ranges from, though? One more thing before we actually run it. I want to see, where does it get its ranges? Because one thing is, it's going to print them, so that's good. I don't know, it's just hard-coded. Okay, I was going to say, I don't think it doesn't look like it's, like, setting the range based on the lights at all. Like, theoretically, it could turn the lights on and then take a reading and then subtract a little bit and use that as the high threshold, and it could do the same thing with the lights off for the low threshold, but doing that. Did we save CodePy? Yeah. So yeah, we'll have to see if those actually are good numbers or not. And the camera will probably freak out a bit since the light's changing so much. It's going to be hard for it to stay focused, but it'll try to do its best. And it does seem like interrupt pin is always false. We did not make it anywhere near 100,000 though, so possible we just need to use a different range. And it's also possible that the int deasserted for all in ranges. Int pin. So the interrupt pin is pulled high. Interrupt pin is pulled up, but this is saying that it is false in all these cases, which means that it's tripped, which is odd. We would expect it to be false up to here, I think. For all of these, I think it should be false because it should be tripped because it's below the low threshold, which we do mark successfully here. Then we cross the low threshold, so we're inside the range of the two thresholds, in which case this pin, I think, should be going back to true because it should be getting pulled up. They do increase monotonically, but the actual pin is not doing what it's meant to. It does not seem like. And let's just double check. So proximity sensor, light, so proximity disabled, light sensor enabled. Is on RGB mode. I don't know if that's for sure what we want. Resolution is this, measurement rate is this, gain is this, light interrupt threshold. So there's low and high, interrupt channel on green, persistence is that, and then it does enable it right there. Clear the state before starting. So these sensors, a lot of them, when you read the status, it will clear the current flags, which will send the pin back high if it's not being tripped. Innocent steps. So it's going to go set the pixels to the thing, sleep for this, clear the interrupt, sleep, pick the average green, read the interrupt pin. Okay, so these are just hard coded based on the thresholds, and then this gets added to a list to get printed later. And then we print brightness, green, it's just not pin value. Oh, this is inverted already. Read interrupt. Return true if the interrupt is currently asserted, which means the pin would be false. Yeah, that should be right. Okay. So that's not actually the pin, that's the asserted state, and it is... So in that case, it should be actually false up to here, not true, because it's not the pin state, it's the asserted state. So it should be false up to here, and then it should switch... No, wrong way around. It should be true up to here. Yeah, really, this should not be labeled int pin, since it's actually the reverse of the int pin. It's opposited by that read interrupt. It should say int interrupt asserted or something instead of pin, probably. I'm gonna actually do so that I don't confuse myself further, if I can find the right print. Where is that printing from? Running the ramp. Oops. Oh, I shouldn't have done that, huh? It's gonna mess me up. Brightness ramp, brightness. Where did the labels come from? Running brightness ramp. Running brightness ramp. Are these the labels? These are the labels. Oh, these are... Okay, these are like adding spaces or something. Interesting, okay. I'm not familiar with that syntax. This is like, inside an F string, it's got the curly brackets, but it's doing greater than 8. Assume that's adding space, or maybe a maximum amount of space, because this one didn't get as much. Well, that was very dark. Okay. So yeah, it's never showing asserted. I am going to change the range. Since we can see the range here, I'm actually going to make it so the low is like 10,000 and the high is like 50,000, so that we will hit below, inside, and above. All up here, 10,000, 50,000. Okay. So now we have the full range covered. The actual interrupt behavior is definitely not working correctly. So let's start double checking some things. Is the pin connected? It's connected here. To D8. Okay. Definitely connected to D8. NeoPixels we know are connected to D7 because those are lighting up. Asserted is always false, which means the pin is always true. So let's just make sure that that should be baseline just true. We should be able to take that as fact, but I want to print it just to make Absolute certain. Where is steps? Yeah, the way this is split up is like strange, kind of. It takes readings first, and then it uses comprehension to check. Means I print very easily here. Well, I can actually just do maybe one of this. Interrupt pin.value. I wonder if we shouldn't be, because screen goes. The other thing is there should be interrupt registers as well. Okay, this gets all wonky now with the formatting because I added a column or whatever and I didn't format it the right way, but we can see there now the pin is true all the time. So it is getting pulled up. And it just seems like the sensor is never pulling it back down. All right, so one thing I'm going to do is make sure I have the latest driver. And then we will also try to check. Well, so it's actually reading main status, which is where the interrupts are at on this one, I think. Main status is giving a tuple of booleans, which does give us data ready, interrupt. Logic, I think, means the current state. So for proximity, it will keep track of whether an interrupt has fired since the last time you checked the status, but it will also give you the current state, like is it currently firing, is it currently triggering? Light data ready and then light interrupt. So theoretically, the second to last Boolean should be coming true if this was working. And we are calling clear interrupt here, which is getting the main status, but just not printing it. We could print it so that we can see if it's ever becoming true. So it should be printing in there, should it not? Yeah, I changed it in the... Changed it in the repo on the device. Okay. Okay. The interrupt register is correct. Well, I'll let this finish so I'm not trying to talk about it while it's scrolling past, but and I know the formatting is leaving a lot to be desired here, but it is working correctly. So when we're below the low threshold, this pin ultimate, the second to last Boolean right here is true. That's the light interrupt we just saw back here. Light interrupt. So those are correct in all the readings where we're below the low range. There's one at the beginning where it trips also, just in the ambient light is not is below the range right here. So it clears at the very beginning. Then it sets the brightness to 0, which would be the same brightness it's already on. That one also is true. Then it sets the brightness to 5%. That one is true. 10%. That one is true. 20%. This is now above 10,000, which means it's no longer going to trigger because it's inside the range. It's not below the load threshold. So this switches to false now. We have 1, 2, 3, 4, 5 actually that are in the false range. I should use a lower thing. I should use like 30,000 maybe. But in any case, we have like 5. So add false here was the first one, then false, false, false. 1, 2, 3, 4. 2, 3, 4, 5. No. 4? 5. We don't clear after the last one. Yeah, we don't clear after the last one. There would actually be... No, is that right? Because this is true. Clear... Actually, clearing right before it is what we're doing. Okay. We're off by 1 here somehow, but... For the most part, it is basically working. So we would have cleared here for the first time. And then we would have cleared here, actually, for the second time. Okay. Okay. This is way up here. So the first one was actually this. So this is the first reading. Okay. Yeah, I think back on track now. So this is actually the first true reading, not the beginning of the script. The beginning of the script is up here. This is the first true reading. It is tripped. So 1... is tripped, 2 is tripped, 3 is tripped, and 4 is also tripped. But we do this. Do this at an awkward time though. We're clearing before we take the next reading. So we're still tripped here because it's actually before... Well, it's not before we've changed the light, though. We have changed the light. It's before we've done the average and stuff. Does that matter? Not sure. In any case, it is changing, and it goes to true for the reading down here when we are above. Only thing that's weird is the number of things we have. 1, 2, 3, 4. We only have 4 falses. But we have 5 readings that are in range. Yeah, I think because of the way we're doing this reading, after we change the light and before we kind of take the next reading that ends up here, we have this weird sort of offset by 1 reading thing going on. But it is basically correct. We end up with tripped for these because we were below the range. We get into the range. We're no longer tripped. We have 2 readings inside where we're not tripped. Or we have 3 readings total, but because of this offset that I'm talking about, we end up with 2 of those. And then we have 3 readings that are above, and we are tripped on all 3 of those. The registers are correct, but the pin's not moving. Let me... say if we pull this down. I was thinking about if changing that's going to make any difference, but I don't think it will really. Is there anything interesting about the interrupt pin on this? Dedicated interrupt pin. One of one match. Open drain. Well, not in a second. So we have 0.6 seconds of settle time. So after it changes... After it changes, it will wait 0.6 seconds. After it changes the lights... So I don't think we can... Yeah, I think the problem is this. So... I think that when we do this, so we set the brightness, the sensor is doing its thing. It's going to trip the interrupt if it's within or outside the range, right? When we clear the interrupt, it's going to undo the pin. I think by clearing this, it's going to send the pin back high. It's basically going to, it's clearing out the interrupt trigger to say acknowledged, essentially, which is then going to pull the pin back high to wait for the next interrupt. But it sleeps again, though. So it should re-trigger. Re-trigger. Never actually does. I kind of want to try... We move this to afterwards. Does anything interesting happen? No. And it's still always true. This never gets pulled false. Okay. And we still print this first because we've taken data readings here, but we haven't actually printed anything. The print doesn't come till here. I guess we could move this to all the way below that. I would change the order of the prints, but it doesn't really matter, I think. And we basically see the same thing, where the register is pretty much correct, but the pin is not doing anything. Variance interrupt. Oh, variance as in absolute value difference. Are we doing that? I think we're doing that. Doing that? We're doing that. What's if the driver's doing it under the hood? Variance threshold. I have a variance threshold. Variance mode. True versus threshold mode for the light interrupt. So what is that set to? Light variance mode. Right? Sensor though. Or it's not created yet. It's false. I don't know what LS and PS means, really. PS logic mode. PS logic mode output has priority over any other interrupt signal. If PS logic mode is 1, then no LS interrupt can be signaled at the int pad. This sounds potentially relevant. The LS and PS... Oh, proximity? If... Proximity? We have LS maybe light and PS maybe proximity? If selected PS logic mode 1, no LS interrupt can be signaled at the pad. LS and PS as well as PS logic mode are active low at the int pin. A cleared LS interrupt status or PS interrupt status flag also clears the interrupt signal on the pin. So yeah, reading the status will clear it on the pin as well. So I do think it makes more sense to read the pin first and then clear the status. But it should be sleeping long enough to be able to do it anyway, right? Because it's sleeping for 0.6 seconds, which is 600 milliseconds. And it's setting the measurement rate to 200 milliseconds. Okay, what is the PS logic mode? This is page 12 if we want to get back to it. What is the PS logic mode? Highlighting is messed up in this thing. So this is in the configuration interrupt, bit number index 1, logic mode. 0 is normal interrupt function. After an event, the int pad main... Wait, I need to go back to page 12. Did it say it was active low? It should be active... Yeah, active low. No, that's right. That's right. Active low. Okay. After the interrupt event, the int pad maintains an active level until the main status register is red. In the PS logic mode, the interrupt pad is updated after every measurement and maintains an output state between measurements. Okay. So in normal mode, reading the status is what clears the interrupt pin to let it refire. In PS logic mode, it will change the state every time it reads data, no matter if you have cleared or not. So do we have that logic mode? Do we have anything like that? Proximity logic mode. Huh, that doesn't seem right. Interrupt enabled. Is, I guess, proximity. It is for proximity, I think. Variance mode. Light interrupt enabled. Okay, I don't know. This, I don't think actually does apply to us, actually, because I think this is for proximity. That should be getting set to true from this. I wonder if just the pin is bad or my soldering or anything. If we were to pull this down, it would show script for all of these. Gets reset back to true. This is the pin value. That's weird. Script pin.value is what that's printing, right? Yes. If we just switch this to something it's not plugged into, then it definitely should be low, because we're setting it to pull down. So A3, nothing is plugged into A3, so if I set that as an interrupt pulled down, it should just always be false. Okay. So I guess the pull down fails when it's on pin D8 because the APDS, the breakout is pulling it back to high. I guess its pull is greater. Its pull is more gravity or whatever. So it's pulling it back to high, and then because it's never, for whatever reason, because it's not able to trigger it, it's not able to actually pull it low. It's always staying high, even though I put it as a pull down. Hmm. Okay, I'm gonna take a look closer at this. That actually. So I'm gonna unplug this. I mean, it looks soldered fine to me. The weird thing is, I could have sworn I ran these tests the other day and saw it pass, so odd that it's different now. Um, yeah, I guess we want RGB mode because it's keying on the green light channel. We could check the proximity interrupt mode. Are you not allowed to have both interrupts enabled at once? Well, if nothing else, I do think this description of what this does is wrong. Also, it should be underneath like this because then it would make it to the doc strings. So there is room for some improvement here. The documentation would be better if those were string under. That's just how Sphinx does it. And then this is just wrong, I think, because we saw in the datasheet here, logic mode is not talking about inside the window or outside the window. It's talking about when the pin gets cleared. Whether it gets cleared only when you read the main status, or if it gets cleared every measurement. So we should fix that. I mean, it should also be set to false. And it should not have anything to do with what's going on, but it is absolutely set to true. It's absolutely set to true. Why would it be set to true? True the default? 0 is the default, which would false, you would think. Okay, so then this combined with what it said on page 12 now looks suspicious. Because PS logic out mode has priority, also seems more important now, has priority over any other interrupt signal. If selected PS logic mode 1, which it turns out it is, it seems like, then no light interrupts can be signaled at the pin. So how did this get set to true, though? Does this get set to true in the init? No. How did it get set to true? Did anything else in this code use this? No. So weird. I don't know why it would be true. But, I mean, theoretically, set it to false. We make sure we've undone all the other weird stuff we did. That pull. Did I undo that pull? Yeah, okay, that's back to pull up. That's still wrong. We should do this. Well, let me just run it again. Because this printed true and then I changed it to false. It didn't fix it because these are all still wrong. But it should be false the first time now. Yeah, so now it's false. So we set it to false and it stayed that way, which is good. But I wonder, is proximity interrupt enabled? So proximity, but it says logic output mode. How did that get to true? Because it does clearly say default is 0. Or if this is just wrong. Okay, where is this proximity interrupt? So that's bit 0. Is that showing enabled? That is showing enabled. Okay, first of all, it's weird that the proximity interrupt can be enabled when the proximity sensor is disabled. That seems like it shouldn't really work, but try setting it to false also. Maybe also let's print these after this so that we don't have to run it again to see the current value. Yeah, these are both set to false now. But totally we still don't have the pin doing the right thing. Actually, I do kind of want these. That seems like it should be, that seems like it should have been the problem. It does seem like it would cause the exact symptom we had. So, proximity interrupt is, but this is the config. Where's main status? Because this also has proximity data ready. Proximity interrupt. The interrupt. So we should have been, if that's true, we should have been seeing proximity interrupt bit 1, the first index in the tuple, the 1 index in the tuple. So it's false here because we just disabled it. But it actually shows false on all of these as well. Even back here when this was showing true. Okay, we are definitely in crazy land now. Because even here, proximity interrupt enabled was true. But this is not whether it's enabled. This is whether it's fired. Never mind. Yeah, this is whether it's fired. And then we had current state of the proximity logic signal. Sensor interrupt has been triggered. We always have data ready. We sometimes have interrupt triggered. All right, well, I don't feel like we maybe got closer, but clearly have not reached the bottom of this particular issue. This just got me back to page 12. Their feature is the option to deactivate both sensors after the interrupt event occurred. Therefore, bit for the respective sensor has to be set in the main control. Independently available for both sensors. I don't understand what that means. Well, deactivate the sensor after the interrupt occurred. And then you would reactivate it by using this. Yes. Sleep after interrupt. Are these things on? Sleep after interrupt, light, sleep after interrupt. Do light. That's what we care about. Is not on. For a reset. Do we have a reset function? We do. If we... I kind of wonder, were those the defaults or do those get set somehow? I reset right before we print these. Are they through, some of them? I'm out. 28. Sleep longer. Still timed out though. Fortunate. Wonder if we're just completely stuck now. Even if I take this back out, is it still stuck? No. Oh. Answered with an ACK. Is reset set to the right register? Yes. But when we reset, why can we not... Is it just the first one that fails? Or will they continue to fail? Only the first one fails. And they're all false after a reset. So how on earth did those get set to true earlier? Right. Because this script ran a while ago, which set them to true. Because this was a proximity sensor script. That's how those were true. And they are false after a reset. But still, the pin does not work. Which I think is where we have to leave it for the night. But we have discovered a lot. The register interrupts, the registers that represent the interrupt state are correct. Only the pin is false. And the data sheet definitely has these warnings about the pin will not trip, which would have been true for us for a long time, but I did fix it a while ago. I almost wonder if it is worth trying one more thing, which is just the old unplug replug. So that is like completely all the way powered down. Not even a soft reset, just like completely, totally reset. I don't really think it will make a difference, truthfully, but... Yeah, this time, these actually look wrong. Is that true? No, I guess that's not true. It's just we still have this off by one weirdness going on with it. We have these should be tripped because they're below the threshold, the low threshold. Then they should switch to not tripped while they're in the range, which they do. Then they should switch back to tripped once they're above the range, which they do. So yeah, the registers that tell you the interrupt state are correct, just the pin is not reacting correctly. Okay. Well, I will have to continue digging next week, I think. So that's going to do it for today. I will be back on Tuesday. Tuesday morning, 11 a.m. Eastern, 8 a.m. Pacific, 10 a.m. Central, here on the Adafruit channel for Deep Dive with me. Just different time, and I do it on Tuesdays. Scott usually does it on Fridays. As far as I know, Scott's planning to be back next week, so I think that, as far as I know, plans could change, but as far as I know, he's planning on working next week and being back for Deep Dive on Friday. So 1 week from today, I think he should be back here. And that is going to do it for tonight. So thanks for everyone who watched. I hope you all have a good rest of your Friday. evening, and or whatever time of day it is for you. Hope you have a good weekend, and that is all. So long.